morning, everybody.
Good morning.
I have a balloon for you, okay? And I have a quiz for you. Let's get started with the quiz right away. Now, this quiz, you're not going to write anything down. You're just going to talk to the person next to you. So, the game is, I'm going to throw the balloon in the air, and you have to keep it from touching the ground. If it touches the ground, you guys get S, okay? The quiz, right, you're going to turn to your neighbor, and you're going to ask them, after you introduce yourself, the following questions. Go! And I want you to answer this, right? And don't be afraid to be wrong. Why did I have you talk to each other for the first 5 minutes of class? To wake you up. Because it's 8 o'clock in the morning, and who in their right mind comes to class at 8 o'clock in the morning, right? Okay? I'm one of those annoying morning people. I'm usually here around 6:30. So I've already, my breakfast was at 5 and I'm ready to go. Almost lunchtime. No, I mean, waking you up is a plus, but this is physics class after all. It's one of the best sleep aids in the universe. Other ideas? Don't be afraid to be wrong. It's okay. Yeah?
To make acquaintances with people around you, or try to have potential sleep partners as you do?
But this is science, right? We're not supposed to be like talking to each other or nice to each other? Like, how do you know when a physicist is interested in you? They look at your shoes instead of theirs. Right? Science isn't. Why would I want you guys talking to each other? I haven't even introduced myself yet. I'm Mr. Balogh, by the way. Good morning. Why would I want you talking to each other as your first experience in my class?
So we're more comfortable reaching out to each other for help
Why would you reach out to each other for help?
if we get stuck on something.
Because you're going to need each other for help? It's an excellent idea and a truism in this class. You're going to need the people around you. That's how you're going to pass this class. Okay? But that's not the reason I had you talk to each other. Well, it's much more obvious. I'm really an English teacher and I'm just trying to kill time because I have no idea what it is. No, that's not it. How do you know when you know something?
You can teach it.
When you can teach it to somebody else. Am I going to have you teaching each other in this class? Yeah. Yeah, and for those of you that are in an absolute panic right now, I do not mean you standing up here doing something, okay? But when I ask you to turn to your neighbor and do something, right? And you turn to them and you're able to like explain or step through it or whatever, what do you now know? That you know something, right? If you turn to that person and go, I have no idea what I'm doing, what do you now know? You have no idea what you're doing. And that's an important piece of information to have. That's the start of getting knowledge. And so when I tell you that you're going to be talking to each other a lot in this class, and you're going to be teaching each other and sharing information, do you believe me? Yeah, I'll say anything, you get an A, Mr. Balogh. Why do you believe me? What was the first thing you did in my class? Talk to each other, right? How many of you have had a teacher that's, for the first 50 minutes, first class meeting, has told you how interactive their class is going to be, and never once interacts with you or has you interact with anybody else? Right? Okay. So, first dates are so awkward, right? Okay. But the first experience that I set in your brain was one where you were looking at each other. So, what are some of these answers? Where were you born? Where are you from? Just shout them out.
Santa Barbara.
Santa Barbara, cool. Fresno. Wait. You said that like Fresno. Right? No, Fresno! Come on, this place is great.
Michigan.
Michigan.
Long time.
Long time ago. What, like UP or?
No, the mid.
Mid?
Ann Arbor.
Yeah, no, my brother, sister and brother-in-law went to Ann Arbor for graduate school. My other brother-in-law's from Minnesota. Where else? It's not contest, just where are you from?
San Jose.
San Jose? I'm assuming California? Outside the United States?
Mexico.
Mexico?
China.
China.
Thailand.
Thailand. Anybody representing Africa? Europe? Middle East? India? Fresno City College is a fantastic place. I love it. There's so many people from so many different places, and it's just so exciting. It's absolutely incredible. Okay, so what's your favorite thing to do? Drive? Like, are we talking like just driving the mountain roads, or are we talking like drifting?
Roads, both.
Oh, it's drifting on the mountain roads. I like it. No, not that. Okay. All right. Travel?
Sitting around playing video games.
Yes!
It doesn't sound very exciting now that I say it out.
No. It's like the best thing ever, right? Diablo Season 30 starts on Friday. I've been deep into PoE. Monster Hunter is like my best game of all time. I am an avid video gamer, okay? I was there when they invented them and I'm still playing them, so. Yeah. What else? I gather from this is that you're all students, you don't have time for favorite things,
Pretty much.
pretty much, right?
I like reading.
Reading, like fiction, nonfiction, fiction, yeah?
I like to sing.
Hmm?
I like to sing.
Sing, fantastic. Singing is something I picked up over the pandemic. And I think, yeah, 2 Sundays from now I'm performing in church. My mother-in-law is a big musician, my wife's a musician. They roped me into it, so get to do that. Let's see. Very good movies recently. Oppenheimer, okay.
Got to see Vertigo for the first time.
I'm not going to see Oppenheimer. I haven't seen Oppenheimer. I'm not going to see Oppenheimer for many reasons. Most of which are people that know me telling me, don't go see that movie, you will be mad. So, yeah. Seems like all the good stuff's on streaming now. Right? Not so much the movies. Okay, very important. Your favorite place to eat in Fresno. This cannot be your mom or your grandma's house because I'm not allowed to go there. Okay? But what are some of your favorite places to eat in Fresno?
Westwoods.
Westwoods? I find their barbecue too sweet, to be honest with you. But yeah, it's a decent place. Where else? Yeah.
Heirloom.
Heirloom. My wife really likes Heirloom. I'm ambivalent about it. I'm not like a real like fancy food kind of person, right? I'm also not a burger person. I'm sort of in between. But what else? What other places? Come on, I need help. I need date ideas. Right? Herndon and Fowler?
That ramen place on that
Oh,
corner.
like a ramen?
Yeah.
You don't remember what it's called, right?
No,
Okay,
it's on Herndon and Fowler.
Okay, Herndon and I'll go look it
It's on
up.
like the northwest corner.
Ramen Hayashi.
Yeah, I was gonna say,
There
it's
you
just
go.
ramen hayashi.
Ramen Hayashi.
You should go to Doll's.
Okay, these are fighting words. I do like pho better than I like ramen.
I agree.
Just flat out. I think pho's the better soup. But I do like them both, right? I do like them both. And I will go for ramen just about any time. What else? Seriously, I'm in big trouble if I go home today and I don't have 6, 7 ideas.
$5.99,
Pho 99, okay, Pho 99. Pho Paradise, which I think is just up the road there too.
same exact corner.
Yeah, really good.
Go to Doll's Kitchen.
Which one?
Doll's Kitchen.
Doll's Kitchen?
It's salty.
I haven't. I've never heard of that. Where is that? You don't have to look doll, as in like a baby doll, right?
Yeah, Doll's
Doll's
Kitchen.
Kitchen. Nice. Like soul food, like good Southern food kind of thing. Oh, fried everything. Do they have fried okra?
I haven't tried that, but I'm pretty sure they do.
Oh, so good. Okay, all right. This is the start. Okay, so if you have any ideas, right, email me. Why are you here? Be honest. Yeah, somebody said you had to do this class in order to go on with your life, right? Okay? Nobody woke up this morning, yes, I get to be in physics class this morning. If you did that, we need to talk about a change of major, right? Okay? But I know that I have a captive audience, and what's more, you got to pay to be here. But yeah, I get it. What are your future plans? I heard graduate school, right, to get into a graduate program. Can I guess that that's maybe DPT? No, what is it?
Athletic training.
Athletic training, excellent. What are your future plans? Software engineering?
That's cool.
Med school?
Physical therapy.
PT, physical therapy?
Programmer for some software or game design, depending on which one is better job security.
Right. Right now, game design is not looking good, but it'll bounce back.
That's cool.
Vet school?
That's cool.
Oh, med school.
No, that's cool.
Yeah, V with a V, right? Awesome. Nursing, anybody? Yeah? Okay, a few nurses out there. So you'll notice sort of a common theme among those majors, right? Because it seems kind of weird. We've got a lot of medical and then we've got software, right? All these different things. These are, physics, the 2 series is not a prerequisite or a jumping board for the 4 series, okay? The 4 series is what we call for scientists and engineers. So those are your chemists, those are your mechanical engineers, your civil engineers, electrical engineers, physicists, that kind of stuff, right? This class is more for pre-med, medical school, pre-vet, a lot of the things in STEM that we consider to be like technical fields, where you're not so much doing design, but you're actually doing stuff in the hospital, working with people, that sort of thing. And some people get confused, right? That somehow I've got to take physics 2A to get ready for physics 4A or something like that. Now, some of you might be biology majors, assuming a lot of you are bio majors, and depending on where you transfer, you might have to take physics 2 or physics 4. Okay, so if you're uncertain with that, be sure to grab me, and we can go over that and see where you're supposed to be. But I do want to make sure you are in the right class. Is there something that you experienced in a class that really helped you? What's something you like that teachers have done in the past for you?
Study guides,
What do you mean by study guide? Like,
just the layout of the material we're gonna be studying.
Okay.
Upcoming exams.
okay,
Also, like having objectives.
objectives?
Yeah.
Okay.
But I do feel like some professors have objectives and they don't meet them.
That's basically all professors.
Yeah.
Objective study guides. Okay, what else? Making a mental list here. Something that engaged you or just helped you feel better about the class, whatever.
Having PowerPoints on campus.
Mm-hmm.
There's professors that don't, and they see you need to be in class, but sometimes you miss class.
Yeah, well, yeah.
And then you just gotta rely on your
It's
partners.
like, like, professors are like robots, right? We never miss class, right? And you guys miss class, and then we like, why'd you miss class? So we're gonna talk more about these things on Wednesday. Okay, and we'll see if I can't meet some. I won't meet all the objectives, I promise. But because some of them are stupid. Okay, so why did I want to know all those things about you? Yeah, so I can better steal your personal information. I mean, I've already got all your information the school has, but if I'm going to steal your identities, I need more. No, stealing from students, that's a profitable business, right? No, the more I know about you, the better I can tailor stuff to you. Okay, your turn. What do you want to know about me? You've got like 3.5, 4 minutes. You can ask any question you want. Go. Yeah.
What's your favorite Half-Life game?
Half-Life.
One.
Yes. I mean, Half-Life 2 was excellent, but Half-Life was the first one, and it was groundbreaking. Like for its time, it was incredible.
Do you like the original more, or do you like Black Mesa?
Black Mesa is a labor of love. I do appreciate it, but the original is.
Your favorite movie?
Favorite movie was the question. The reason I am hesitating is because I'm kind of like, can you give me a genre? Right? In my top 10 favorite movies of all time, the Lord of the Rings trilogy, Singing in the Rain, Gene Kelly. I mean, I've got the list on my phone. I can't remember what some of these others are, but You've Got Mail. I'm not a big movie buff, but I do enjoy movies. Other questions?
Can you dance?
No. Spoiler alert. There will be dancing in this class. It will be me. It will cause mental trauma, but that's okay. There's a reason for it, and that'll be later in the semester.
Why did you decide to become a physics
So the short version of that story is that I went to college thinking I wanted to be a sociologist. Because I'm naturally shy. I don't like talking to people, believe it or not. But people interest me. Like, why do people do the things that they do and all that kind of stuff? And I went to some sociology professors. I went to some of their classes, and it was weird. It wasn't like people had like free will and they could do whatever they. I didn't like it. And so I wandered around campus wondering what I wanted to do with my life. I knew I wanted to be a teacher. Like subject actually didn't matter. I knew I wanted to be a teacher. From the time I was 14, I knew I wanted to be a teacher. I hated high school and high schoolers. All my design science and dual enrollments, I love you. It's okay. So I knew I didn't want to teach high school. Middle school was also a bad experience for me. Didn't want to do that, right? And I also didn't want to end up like researching for my entire life. So I knew I wanted to be a community college professor at the age of 14, right? The question is, what subject? So after I fell out of love with sociology, I wandered around campus and I heard a lot of screaming and explosions coming from one direction of campus, and I wandered over and there was a bunch of physicists and engineers and all that stuff over there. And I found my second love, which is physics. Thought I wanted to be an engineer because I really like working with my hands and building stuff. But I couldn't stop asking why, and the engineers were getting annoyed with me. Because engineers are all about how. They really don't want to know why. They just want to know how to do it. And I was like, well, why does it work that way? And they're like, go talk to the physicists and stuff. That's what I did.
Where did you go to college?
I started at Cabrillo Community College over near Santa Cruz. Did that for my first couple years, and then took a couple years off to serve a mission in the Philippines, and then went to Brigham Young University, which is in Utah, and got my bachelor's degree from there, got my MS, master's degree from there, and I was on my way to a PhD when I got a JOB. Right here. Min quals for teaching in the state of California's master's degree. I started applying, got this job, and never looked back. I am not a doctor. I am a master. You don't have to call me master anymore. That's easy. Any other questions?
Your favorite hobby?
If it isn't video games, okay. So I have a sub hobby in my video games. I really enjoy flight simulation. So I actually have a home cockpit. I fly in VR, all that kind of stuff. So if it isn't video games in general, then it's definitely flight simulation. I love the outdoors, hiking. I used to climb, big mountain climber, but I got old. So yeah, between outdoors and video, I think those two things seem like at odds to each other, right? Video games and then doing stuff outdoors. But I have a Steam Deck. I can do both now. Yeah.
All right. Do you have any game recommendations where it's best if you just go in completely blind?
Completely blind.
Like less you know before going in, the better.
Yeah, that's a good recommendation. Vampire Survivors.
That's great.
It's addictive and it's easy, and I think the less you know, the more fun and the more legs that game has. So, and it's like what, $5 or something? Right? So, yeah, that would be my recommendation. You know, a lot of times, I assume my students kind of look at me like this. They see me like this, right? And like Luke Skywalker, right? Yoda couldn't be believed at first, right? He was too old. What could he know? How could he understand my situation? And I get it. I mean, when I started teaching here, I was 25, 26 years old, and all my students believed me. Everything I said, right? Read the book, do your homework. Oh, they did it, right? And then I turned 40 and you guys stopped paying attention to me, right? You didn't believe anything else I said. So do try to overcome that. Sometimes I worry that my students see me like this, right? Snap my fingers, half of you failed. right, kind of thing. But again, I hope that's not the case. And now I'm starting to wonder if my students are starting to see me like this, right? Because everybody's watched Oppenheimer and all that kind of stuff. But the more you know about me, the more I know about you, the better we're going to be able to communicate, right? And so for some of you, we're going to be together for a year. Oh, that's not true. I'm not teaching physics 2 next semester. We're going to be here this semester. But 18 weeks is still a long time, right? And having that connection is real important. All right, so we're going. Okay. One of the other ritualistic things that we're supposed to do is go over the syllabus. Because, of course, we posted the syllabus to Canvas, and I've noticed that students are able to ignore the syllabus online just as well as they're able to ignore it if I were to hand it out on paper, so that's why I don't hand it out on paper anymore. But let's just go over a few things. A lot of this stuff we're going to talk about tomorrow in more detail because in lab we've got time for it, right? And I'll be able to answer all of your questions. But if you have a question right now, like you're not certain about this class, you got to throw your hand in the air. I have struggled for 23 years of teaching on how to make this part of the class interesting. And as far as I'm concerned, there's no way to make the syllabus interesting at all. The syllabus is like the most dull thing in the world, right? So I apologize. I will be talking a lot today and tomorrow about stuff that is important, but it's not like I can ask you to turn to each other and discuss the syllabus. Okay, so let's try to fly through some of these things. So we'll talk about the text, attendance, and homework tomorrow, okay, in lab. We'll cover it because we'll have more time to go over everything. Let's talk about exams, grading, and some miscellaneous things, okay? I don't drop any exams. There are 5 of these exams throughout the semester, 1 exam per unit of material that we've organized the course into, okay? And I allow you to bring, call it a summary page, call it a notes page. I've always called it a cheat sheet. You're not cheating because I'm allowing you to bring it, right? But this is something that you get to put on your, you put anything you want on that sheet, 8.5 by 11 sheet of paper, okay? Front and back, whatever you want, whatever makes you feel comfortable when you come in to take the exam, okay? We'll talk more about these later and like ways to, important things to put on them or whatever, but everybody's brain is different. The way that you absorb the material is different. And so this sheet's going to be tailored to you, right? And your way of learning and what you need. So you won't be, you'll have something with you on those exams. There is a very, very scary number on this screen. What's the scary number? 75%. But it is not the most important number. You want to guess what the most important number is? It's not lab reports. More on that tomorrow. It's homework. Homework is the most important thing in this class. Homework is where you are going to learn. Homework is where you're going to figure out how much you don't know. Homework is where you're going to figure out how much you do know. Homework, homework, homework. You treat the homework well. You start the homework early. You work on it throughout the week, and you will be paid back with good scores on the exams. I designed the homework to be harder than the exam questions you're going to hit. And so if you understand the homework, if you know how to do those problems, you know how to do the exam problems. I'm not going to say it's going to be a walk in the park. Exams, their physics exams are hard. Physics is hard. Everything you've heard is probably true, right? But I'm trying to over-prepare you, right? I'm trying to get you to that point where you can slide into that exam feeling confident. So homework is the most important number on the screen, and you are going to be doing a lot of it. And by a lot, I mean you're going to be spending a lot of time on homework in this class. So late policies. I don't do late homework because the homework auto posts the key, the complete solutions to everything, as soon as it's done. And you can go back and review that at any time you want, right? So we're coming up to a test, boom, you can do that, right? So what I do is I drop your 2 lowest homework scores. You have a homework assignment per week in this class. And so that means basically kind of like 2 weeks if something goes wrong. That being said, that doesn't affect your grade negatively in the moment. But physics, pretty much every science class, if you've had like chemistry, this is very similar. You can't miss a week. This class is a marathon. It is not a sprint. It's like climbing a ladder. You need to hit every rung on that ladder or you are in danger of falling. The stuff we do in chapter 1 we're going to use for the rest of your physics career. The stuff we do in chapter 2 we need for chapter 3, and 2 and 3 are needed for 4, and so on and so forth. Like, it just builds on itself. And so missing a week isn't an option in this class. And I'm not afraid to say this, right? But guys, you probably all had Common Core, but before Common Core there was no child left behind. I'll leave you behind. Like it's just, there's a certain set amount of stuff that the state of California tells me that I need to cover, and if I don't, they'll come and they'll say, well, these students didn't take a class, right? And so I've got to make, and the train pulls out of the station, and it just doesn't stop for anything, okay? And it's going to feel like that. You're going to feel like you don't understand, you have no idea what's going on, you're going to start developing imposter syndrome because you feel like you don't deserve to be here, because you know, that's normal, okay? I've been doing physics for almost 30 years now. I'm not sure I understand anything, right? It's just, you hold on for the ride, okay? And there'll be certain things that you'll know whether or not you're getting it. And I'm here to help out with all of that. Does anybody want to summarize my exam makeup policy in one very simple sentence?
No.
Don't miss exams. Okay, we'll talk more about that tomorrow. I'll show you the schedule so you know exactly when the exam dates are happening. And if somebody's getting married or whatever's going on, right? And you know ahead of time, you've got a team schedule, you need to meet, whatever, we'll sort it out, right? This late policy is for those that come out, oh, we had a test yesterday, okay, go take it. Communicate to me, right? Tell me what's going on. Morning of the exam, car breaks down, 3 flat tires, whatever it is, right? Shoot me an email. Right? I need you talking to me, and I can revoke some of these penalties. The makeup exams are always more difficult, but I can eliminate that penalty to your score. The trick here is there's 5 dates you really got to nail. Try not to miss those days. And things happen, I know, but really, if you want the best score possible, you really want to nail it on that day. Nobody uses phones anymore, right? Like actual telephone calls to people? Or voicemail? I let my voicemail fill up. I don't even check it anymore. Technology. Are you allowed to use your phones in class? Your iPads, your computers, all that kind of stuff? Absolutely. I mean, I'm using it. Okay. I've got an iPad. I'll show you what I do with that tomorrow. Yes. Right? Let's use these wonderful things that get us all of this information in one place. I mean, the AI is starting to just pull it all together for us, right? Don't let ChatGPT do your homework. Oh my gosh, that is a dumpster fire right now. I mean, eventually it's going to get there, right? But like, right now, oh my gosh, it's programmed by an English major. Like, it's just, oh my gosh. Okay? So, but like, yes, bring it to class. Use it. You're going to probably have the e-text. Nobody reads a textbook anymore, right? Okay? So you'll need reference information, all that kind of stuff. Bring these devices, have them ready to go. Don't use your device in class for something that's not class-oriented, because it could distract people around you, right? You're playing a video game, watching YouTube, doing stuff. On the other side of those 2 doors is an entire universe. You can go out there and do that, right? This is the place where we come together to focus on this subject and try to arm you with as much skill and information to make you successful as possible, right? And so please, I empower you. If somebody around you is using their device and it's distracting you because of what they're doing, politely turn to them and say, you know what, Mr. Balogh said, you know, no distracting stuff in here, right? could you please put that away or get on task or something like that, or move to the front, we can't see you go, right? And if they sneer at you or call you a bad name, let me know, I will kill them, right? Like this place, this room, this time that we have together, this is sanctified time. We don't get this very often during the week. Some of you are like, it's way too long, this should be out. But this is our time to make these things happen. And to bring all of those outside influences in here to distract us, that's not a good use of our time. I want my class to be that place not only where you can learn the best, but where you feel safe, where you feel accepted, where no matter what you look like, how you act, what you believe, you can come here and you can learn, right? That's our goal. And anything that disrupts that goal, I need to know, right? So if you're feeling uncomfortable or anything, you need to let me know so that we can make corrections. Okay. Little edit here, okay? You are more than welcome to come up and ask me a question, right? As I'm getting ready for class, right, or something, come up. You got a question, come. If it's a question about homework, I'm going to tell you that I don't have time to answer it, right? I'm getting stuff said, I got to get the computer working, all that kind of stuff, right? If your question is going to take too long to answer, I'll let you know. I'll say, you know what, I can't answer that right now, but hit me up after class or shoot me an email, right? I made a mistake last semester in 2A. I put that up there, don't ask me questions before class, and so people didn't talk to me at all, right? I always want you to feel welcome to come up and approach me, right? But especially homework questions. Hey, Mr. Baird, can you help me with homework? The answer is no. And for all the world, sometimes it's going to look like I'm up here goofing off before class. I'll be talking to somebody, right, about a movie or video game, and you're like, oh, I can ask him this physics question, right? What's going on there is I'm mentally preparing myself for what's about to come, right, okay? Especially right after this class, I have 10 minutes to transition from Physics 2A to Physics 2B, and it happens right here, the 2B students are gonna be coming in. And so I've gotta transition from 2A material, mechanics, into 2B material, electricity and modern physics. I need a psychological clearing of the air, right? So I'll be setting up stuff and I'll be goofing off. Please come up and ask me questions, but generally, if it's like a physics question or question about the homework, I'll probably say, hey, you know what? Come to me at this time, or shoot me an email, or come to my office hour. If it's a question of like, my homework isn't working, I can't access the book, I don't understand what's going on in the class, ask me those questions. I can usually fix those pretty darn fast, right? But I do want you to feel welcome to approach me. It's just realize I might tell you, hey, you know what? I'll answer that a little bit later. I've got some other things I've got to do right here. There is this thing that happens called grasp, which I forgot to change the room number for. This is okay, so this gets a little bit confusing. My office hours happen during this time, but my office hours start at 7 o'clock in the morning for those that have jobs that start at 8 and they want to swing by and just knock off a couple of things before they go in, right? So my office hour starts at 7 a.m. in that room, S230. That's actually not my office, that's a classroom. But at 8 o'clock, other physics teachers and our tutors come, and that room is dedicated to nothing but physics help on Fridays. I strongly encourage you to block out like this time, right? 8 to 9:15, Monday, Wednesday, Friday. I know it's not in the schedule, right? But block this time out, come to Grasp on Fridays, get help. Students who come over and over again say things like, I couldn't have survived without it. Oh my gosh, it made it so my homework went so much faster or easier, or any of that kind of stuff. Grasp is on Fridays. Homework is usually due on Saturdays. That's on purpose. So that we're working through the week, you're struggling, right, trying to get stuff done, and then Friday comes and we dot the I's, cross the T's, fill in the blanks, right, help you through it so that you can get this thing turned in and done for Saturday. It is phenomenal. My old office hours, I could maybe fit 2 or 3, 4 of you in an hour. I could 20 to 30 per hour, easy in class, right? Because there's me, there's the other physics teachers, there's the tutors, right? And we can all help you get through this stuff. So take advantage of it. It's free, right? The tutors are in the tutorial center during the week, and on Fridays we bring them over here. Because in the tutorial center, if a physics tutor doesn't have any physics students, then they have to tutor math. And you're in competition with the tutors for the math stuff, right? So we bring them over here so they don't have to do any math. Well, they do math, but not that math. What the heck is going on in this class? The Far Side was a fantastic comic strip back in the day. And I know this one's kind of hard to read. I'll read the caption for you. But what gives it away that these are scientists? The lab coats, or that they're white old men? We're trying to change that. We're working on it. But they're staring at a chalkboard, and there's a bunch of math on the board, right? And what does all of that math equal to? 0. Okay. This has happened to me in physics, by the way. It's been 3 pages all to find out that it was equal to 0. Down here it says in the caption, no doubt about it, Ellington, we've mathematically expressed the purpose of the universe. Gad, how I love the thrill of scientific discovery. This class is going to feel like this sometime. You're going to be in here, you're going to be like, what choices have I made in my life that has brought me to this? Because I've done nothing but math, and I don't understand, and where's the explosions? Like, I thought physics was supposed to be fun, right? There's not going to be any explosions. Let's just get that right off the bat, okay? That's nuclear physics, physics 2B, okay? What we are going to do, okay, is study what? Like what's the word that seems to be repeated up here? Motion, okay? Physics 2A is what we call mechanics. This is the physics of the everyday. Cars speeding up and slowing down, runners and how they move, get their energy and their momentum going, waves and sound, these heat and calories from our food, basically everything that has to do with motion. Okay, we use some fancy words to describe some of them, right? But this is all about motion.
Do we get to do the thing where we swing a pendulum right in front of someone's face?
Yes, we're going to do that. We're going to be taking noses out left and right. Okay? So those are the 5 units of the course, right? We're going to spend the first 3.5 weeks doing kinematics, and then we'll spend 3.5 weeks doing Newton's laws and so on and so forth. I'll show you the schedule tomorrow, right? Laying out exactly kind of which chapter I'm going to cover when and all that kind of stuff. But what I want to do now is I want to get started. Like, I'm going to start lecturing on some of the chapter 1 stuff here, and we're just going to go for it so you can start sinking in some of this stuff. So, and we're going to talk a lot more tomorrow about taking notes and what sorts of materials I've got for you and all that kind of stuff. But we need to start getting your brain into the mode of science and doing this stuff. Now, I do want to say before we begin our journey together, chapter 1 is not something that I really consider to be physics. Chapter 1 I consider to be a review more often than not. If you've had any kind of science class in middle school or high school, then you probably are familiar with things like converting units. You had to take trig, or at least pass some sort of trig class in order to be here. So we're going to review your trigonometry a little bit. And actually, I'm going to simplify trig greatly for you and make you feel like your math classes were a waste of your time. Third day. But I will teach you something that's perhaps new to you called a vector, right? But this first chapter is really a warm-up. And you'll notice tomorrow when or maybe you've already seen it on Canvas, chapter 1 I do break up into kind of 2 parts, okay? We're going to cover the vector part a little bit later after we do chapter 2. We'll do first part of chapter 1, put a pause on that, do a little bit of homework in it, and then we'll come back to some of the other parts of chapter 1 later, right? So just kind of keeping that all in mind. Now, as an expectation and sort of my role, right? What's a teacher supposed to help you do? Understand? Learn? What is learning? Don't answer that question, people. We're still trying to figure it out. A teacher's job. Okay, so I'm going to use a violent analogy. I apologize for the violent nature of this analogy, but it's appropriate. Somebody's told you that you have to take physics, and that's like a minefield. Okay, there's a field, and there's some mines in it. You don't know where the mines are, right? And there's somebody on one side of the minefield that says, "Oh, you want to be a doctor? You want to be a nurse? You want to be a physical therapist? You want to be a programmer? You've got to get through this field. Good luck." Right? My job, right? My role. What have I done? I've gotten through the field, right? I made it safely to the other side. So my job is to point, right? Is to walk out in that field and go this way. Not over there. Here. You have to walk the field. You have to read the book before you come. In some way, shape, or form. Because I cannot do everything for you. I can point out, I can tell you where the danger lies. But you have to do a majority of the walking. So don't fall in the trap of thinking that you can just come to class and be okay. On Thursday, I want you to come here having read chapter 1, not the vector section, but the units and the trig sections, right? Maybe you'll understand, maybe you won't. When we get to chapter 2, I want you to look at chapter 2. See what kinds of things you're up against. Are you going to understand everything from the book? No! Physics textbooks suck. But I need your brain to have seen terms like velocity, acceleration, kinematic equations. You won't know how to use them. You won't understand what they are. But your brain will have seen it. Even reading the summary, right, at the end of the chapter kind of thing. And I know you're sitting there going, Mr. Balogh, oh my gosh, he's so old. He's talking about reading. I watch videos, Mr. Balogh. That's how I learn. Fantastic. You know what this book has? It has pre-lecture videos. I'll show you where they are tomorrow. I need you walking the walk. Okay? So that when we come together, we can focus on those parts that I know you are going to struggle with. I already know where the hard parts are, right? And we'll spend our time on those. Some of the easier stuff, I'm going to have you do on your own, right? And you're not going to be like, well, what's the easy part? What's the hard part? It looks all hard. Stuff we're covering in class is the really hard part. And if I don't cover it in class, it probably means it was an easier thing that you're supposed to pick up, right? So I tell you all of that and realize that today nobody's read anything, nobody's accessed the book and all that kind of stuff, so I'm just going to spoon feed you, right? Okay? But really, coming prepared that way, getting your brain exposed initially and then having me go over it, much better way to do things. What is this? Good job. It's a meter stick. How do you know it's a meter stick? Because it's a meter, right? Okay. And any yardstick that comes in here, I break across my knee. Because there are 2 kinds of unit systems in this world. They are the metric system, or the SI unit system. And, what's the other one? Stupid. Okay? Anything that's not metric is stupid. Okay? And why is that? Oh, they're accurate. Okay. So, how many centimeters are there in 1.67 meters?
160.
How'd you do that?
It's a very easy conversion rate of just 100.
Yeah, because there are 100 centimeters in 1 meter, and that basically just means I move my decimal point around and I'm done, right? Okay? How many inches are there in 4.78 feet?
Mr. Balogh, it's not on.
This happens from time to time. It's a technical difficulty, and I know how to fix it. And it takes about 30 seconds. You guys having a good day so far? Yeah? How am I doing? Thumbs up, thumbs down? Kind of keeping you awake a little bit? I know the jokes are old, but you know, is what it is. Why is this not quitting? There we go. Technology is wonderful. Technology makes my life better. I know I will have lost it completely when I walk in one day and I just refuse to do anything with technology and I just go straight back to the whiteboard, right? And just let everybody suffer. It'll be glorious for me, bad for everybody else. Okay. Will it work now? Stayed white? Tell me I can't fix stuff. Okay. What did I don't even remember what the number was. 4.76 feet. How many inches is that? Why can't you do that real fast? Because it's stupid. Right? How many inches are there in a foot? Why? Why? This is dumb. How many ounces is there in a pound? Why? Why is the metric system so good? It's based on powers of 10, right? Those 10s make it much easier to move forward and backwards and around and upside down, okay? So, okay, couple things here, okay? First of all, that's dumb. And we have to use both. Unfortunately, we just have to use both. And why do we have to use both? America. So, they tried to convert in the 1970s. It didn't go over well. There were a bunch of bullet holes on the road signs where all the metric measurements were. There are, I beg of you, this has been a problem. This is like a post-pandemic problem we've noticed. The metric prefixes seem to be unknown to people now. We didn't really have to even talk about this. But what I mean by metric prefixes, like kilo, like that stuck on front of like the word meter, so kilometer or kilometer. What does kilo mean? It means 1,000 or a power of 10 to the 3, right? So how many grams are in a kilogram? What does the word kilo mean? 1,000, right? So instantly in the word, you know what the conversion factor is there, right? There's 1,000 grams in 1 kilogram. How many meters are there in a kilometer or kilometer? 1,000, right? It's just that number. So there's another one that you know, which is mega millions, megabytes. What's mega mean? This is where it all falls apart. It's a million or 10 to the 6th. So how many miles are there in a mega mile? 1 million. It's right there in the prefix, right? And then there's another one, giga, as in gigahertz or gigabytes. It's a billion with a B, or 10, a power of 10 to the 9. Tera is trillion, 10 to the 12. Okay? You don't need to worry about tera, okay? Although terabytes are around, you can do anything about computers, okay? So, I don't require you to memorize anything in my classes. I'm not gonna ask you, what's a mega, I'm gonna ask you to convert back and forth, I'll give you a conversion vector. But like, memorization is not gonna help you in this class, okay? So you don't need to memorize equations, you know how to use them. Some people come back and, Mr. Balogh, could I memorize them instead? No. I want you to know how to use them, right? But you will make your life so much easier, faster, and smooth if you know your metric prefixes. And you only really need to know 6 of them, okay? You need those 3, kilo, mega, giga, okay? And then there's kind of the other direction, as it were, okay? Going small. So there's milli, like a millimeter. It's 1/1000th, or 10 to the minus 3. So how many millimeters are there in 1 meter? There's 1,000 millimeters, right? Or a millimeter is 1/1000th of a meter, okay? But that word milli means 1,000, but it means the smaller 1,000, right? Not the bigger 1,000 like kilo does. And then you probably heard of a micron or a micrometer. What's that? Good. Understanding the pattern, right? Okay. So a micron or a micrometer is 1/1,000,000th of a meter. When they say that the human hair is approximately 80 microns in width, right? It's 80 times 10 to the minus 6 meters in width. And then the other one is nano. Nanoparticles, nanotechnology. Nano means 1/1,000,000,000th or 10 to the minus 9. So if I've got 65 nanograms of carbon, that's 65 times 10 to the minus 9 grams of carbon. You just, boom, that word, that prefix literally just means attach that power of 10 to it, and away you go. So you can do really quick calculations with what's going on, be able to move back and forth. Okay, but let's say that we have 1.67 meters, and we want to take this 1.67 meters, and we want to get it into feet. We've got to go like back and forth, right? Help somebody out, translate between the things. How do you convert from meters to feet, let's say?
Like 3 meters per foot.
Hey Siri, how many feet are there in 1.67 meters? I turned your voice off. 5.48 feet. That's how you do it, right? Yes, that's how you do it. But can you do this on an exam? No. Okay, right? So we do need to learn how Siri did it, right? How does Google? Because Google will do it, right? You type it right into Google, boom, it's done. Okay, and I think that's wonderful. I think that's fantastic. But I also think it's really fantastic that we know how Siri and Google are doing it. Okay, so what we need is a conversion factor, and I think you were already trying to tell me what the conversion factor was. We can go look this conversion factor up. Okay, and 1 meter is equivalent to 3.281 feet. Those are numbers that are established by the government. There is a National Institute of Standards and Technology that is responsible for setting all of the base units and getting their measurements correct for time, for length, for everything. Did you know that the United States has been on the metric system since before World War I?
Where?
Everywhere. What is the definition of an inch? Yeah, nobody knows, because nobody cares. An inch is I don't remember exactly what the number is, 2.52 centimeters. What's a pound? It's referenced straight back to newtons. What are feet's referenced in? Meters. Every single unit we use in the good old USA is based on the metric system. We don't set our own standards. The metric system is defined by universal constants that don't change, like the speed of light and other things, okay? But our system of units references back to the metric system. So we actually use metric everywhere. It's just we have a different name for it and it's dumb. So how do we use this conversion factor? You might find another one. Google might tell you, or more likely ChatGPT will tell you, something completely wrong because it just makes up numbers. That 1 foot is equal to 0.3048 meters. That is the correct conversion factor, by the way. So how do you know which one to use, when and where and how? Well, the answer is you don't. The answer is you always multiply. That's the rule. And you're like, wait a second, wait, Mr. Balogh, I learned in some of my classes that I had to divide sometimes. What is division? It's multiplication by an inverse. Just like subtraction is what? Adding negative numbers, right? So we're always going to multiply. It's just sometimes we might be multiplying by a fraction. It's okay. But what you do is you start with what you have, 1.67 meters, and you multiply by a ratio. And how do you know what to put on the bottom and the top? You look at the units. What do we want to get rid of? Meters. So where's meters going to go? On the bottom, right? And that means feet are going to end up on the top. Now, what number do we put in the bottom? Okay, draw a line down the middle of the class, get your calculators out, okay? Everybody on this side of this line, okay? You are the calculation in red, okay? Everybody on this side of the line, you're the calculation in black, okay? Got it? Right? So, for the red calculation, we're going to put 1 meter on the bottom and 3.281 feet on the top. I'm using the top conversion factor up here for that calculation, okay? But for the calculation in black, again, we're going to put meters on the bottom, and we're going to use the other conversion factor. So what number goes in the bottom? 0.3048, and 1 foot goes on the top. Okay, people assigned to the red, people assigned to the black, do that calculation. So red, you're doing 1.67 times 3.281, and in black, you're doing 1.67 divided by 0.3048. Somebody red got it? What is it? 5.48. Do I have a second? Anybody else get that? Yeah? Good? It's going to be feet because the meters canceled out and I'm only left with feet, right? Okay, and people, black calculation, what'd you get?
5.479002625.
Okay, more or less the same number, right? Okay, also in feet. This isn't magic, this is science. It doesn't matter which conversion factor you use. What matters? Where you put the units, right? Getting the units to cancel, right, top and bottom, and getting the numbers in the right spot. So, as another example, okay, so let's say that we know that something is going 60 miles per hour. And we want to figure out what that is in kilometers per hour or meters per second. Meters per second would be the standard SI unit, okay? So what do? We want to get this into meters per second, which means that we're going to need some conversions. And one of those conversions we can look up is that 1 mile is equal to 1.609 kilometers. All right. So we're starting with 60 miles an hour. And we're going for meters per second, so miles per hour. We've got 2 units here. Which one do you want to do first, miles or hours? Miles first? Doesn't matter, let's go for it, okay? So in 1 mile, we know that there's 1.609 kilometers. But now we need to get from kilometers to meters. Kilometers, kilometers, right? Where am I going to put the kilometer? On the bottom. Notice how I just kept multiplying? I'm just going to keep tacking on my conversion factors as I go. So in 1 kilometer, how many meters are there? Kilo. It's 1,000. All right, let's stop and check. We got the kilometers out of the way, we got the miles out of the way, and we're at meters, aren't we? That's where we want to be. Now, right now we're in meters per hour. So how do we get rid of the hours? We multiply. What are we going to put on top? Why are we going to put hours on top? Because it's on the bottom to begin with, right? We want to get rid of it. We want it to cancel out. So hours goes on the top. And is there a conversion? Is there something we know about hours and minutes and seconds and all that kind of stuff? Okay, 60. Okay, who did that? Like seriously, why is there not 10 minutes in an hour? And 10 seconds in a minute? Why 60?
That probably correlated from some other place that used 60.
Blame the Babylonians. It was the Babylonians' fault. They didn't invent time, but they did really were the first civilization to really nail down the mathematics of time. And to them, 60 was a very significant number. They used base 60 mathematics. Base 60. $1775. We are telling King George where to stay, right? And we go so far as to start throwing their tea in the harbor, right? And starting a revolutionary war and all that kind of stuff, right? Okay. What's the one thing we don't change? The unit system! Everything in green uses metric! The time has come! America. And Myanmar. Oh my gosh.
Why did Myanmar and Liberia use that?
Myanmar, which is now called Burma, and Liberia, they just, yeah. I think Burma's actually, they're changing over. The people we kicked out, the British, right? They used the metric system. Where was I? 60. See how easy it is to set me off? How many minutes are there in an hour? 60 minutes, and then for every minute, how many seconds? 60 seconds. Okay, check everything. Hours, minutes. Be careful with miles there, meters there. So what am I left with? I'm left with meters and seconds. Is that what I want? What am I going to do with my calculator? 60 times 1.609 times 1,000 divided by 60 divided by 60. If you have a TI calculator, I wish you the best of luck in getting a right answer. Because TIs are notorious for all those parentheses problems. Okay, be careful, right? This turns out to be 26.8 meters per second. We haven't started physics yet. We're just really reviewing some units. On Thursday, I'm going to finish up chapter 1 pretty quickly and jump straight into chapter 2. So really, look at chapter 1, ignore the vector stuff, so skip over it for now. Start looking at chapter 2, velocity, acceleration, motion, that sort of stuff, so we can get into kinematics. Tomorrow, be there tomorrow at the lab you are registered for, or the lab you're trying to get into. Have a fantastic rest of the day.